But yeah, under the Xyst website, it seems to say, oh, we've been, oh, it might be. Oh, there's Hannah.
Hi, Digby.
Hey, Hannah.
Let's see. Looks like we've started, so.
Okay.
Hello, everyone, and welcome to the World Parks Academy webinar series. My name is Hannah Cleveland, and I'm hosting today from the Epley Institute here in Bloomington, Indiana. Before we begin, let's make sure everyone can hear us okay. Digby, you can hear all right. How about Evan? Can you hear us?
Eric, yeah, I can hear you.
Eric, okay, hi, welcome. All right, great. And looks like everyone here today is from New Zealand or Australia. Eric, are you from New Zealand?
New Zealand, yes.
Okay, well, welcome. We recommend saving all questions until the end. If you have any trouble throughout the presentation, please let us know in the chat box here, and I'll be monitoring that as we go. Now I'd like to turn it over to Paul Wilson from Xyst. He's a senior consultant, has been in parks planning and lighting design for 25 years, and we're happy to have him here today presenting on lighting and design in parks. So thank you, Paul.
Thanks very much, Hannah, and kia ora koutou. Welcome to you all. It's nice to see some familiar faces here also. So welcome to you, Digby and Eric. So I'm coming to you from Gisborne today, which is very appropriate because it's the first city in the world to see the light. And though today it is a very grey, cloudy day, so didn't see the sun come up this morning, but I thought it was kind of appropriate to be delivering a lighting seminar from Gisborne. So the learning objectives that we have for today are to understand some basic lighting principles and terms and identify opportunities, consider risks when using LED lighting, which is, as you know, becoming particularly popular now, and use some lighting evaluation methods and asset management principles to make good decisions. You want to be able to understand how to interpret computer-generated lighting designs, which are what you'll generally see when if you engage a lighting professional, and learn some techniques to minimise the effects of lighting on people, wildlife, the night sky, and neighbours. And lastly, we'll consider the role of lighting in crime prevention. So, you know, this photo for me really represents how what a wonderful thing light is. It keeps us warm. It's a very welcoming part. It's really a key part of our life and keeps us in cycle with all of nature. And we can use light as part of making our places feel more welcoming and more homely. So in a parks and recreation setting, we often use lighting to enhance our public spaces, and whether that's the illumination of trees, gardens and parks, whether it's modern or of historical interest, it all has the aim of enhancing the architectural, artistic and natural characteristics of the areas. And of course, we can also use light to extend the hours of play. So that's the key role of sports field lighting, of course, to extend how much we can use our parks for, and for enable people to walk their dogs in the evening in winter, etc. So we can extend the use of our parks with good lighting. We also can improve the safety and enjoyment of places after dark, and if lighting is poorly designed or executed, then there can also be negative effects on our visitors, our neighbours and the environment. And so having a basic understanding of lighting, which is the purpose of today's webinar, can help us improve these outcomes.
Hey, Paul, this is Hannah. I'm sorry to interrupt.
Oh, that's okay.
I'm not seeing the presentation here. Digby, are you seeing it?
No, I'm not. Scott started.
Okay.
No, I thought he was just doing a prelude to the...
Okay, right. So what would you suggest now? Shall I stop sharing the screen?
Yeah, I would stop sharing and try sharing it again.
Okay.
Oh, this is looking. No, this is Hannah.
How's that now?
It's loading.
I'll just skip back a few photos.
Hmm. You are viewing Paul Wilson's screen. It's just a bit black.
Oh, really? I did get a message about unstable internet, but we are using the same internet that we were using yesterday. And
Did a little practice, did you?
it's a pretty good connection. Normally I have problems with it.
Matthew, are you listening in right now? It should be good to go. Well, it looks like.
Yeah, it's recording. Now we just need Paul. Oh, that's good.
You can hear me?
Working now? Yep.
Yep, it's looking good.
Oh, that looks good.
Okay. So would you like me to start from the top?
Sure.
Okay. Okay, very cool. Yeah, I'll just. Okay, so our learning objectives for today are to understand basic lighting principles and terms, identify opportunities and consider risks when using LED lighting, which, as you know, is becoming very popular worldwide, and use lighting evaluation methods and asset management principles to make good decisions, be able to interpret computer-generated lighting design against international lighting standards, and if you receive professional design advice, you'll receive computer-generated design, so you need to be able to understand what they're telling you. I'd like to learn techniques to minimise the effects of lighting on people, wildlife, the night sky and neighbours, and consider the role of lighting in crime prevention. So lights are fundamentally important. This photo always reminds me of the beauty of light and the ability for it to make us feel warm and comfortable and homely. Light's just such an important part of our life in terms of helping us sleep, helping us wake, and we can use lighting within our parks and recreation settings as well to also make people feel welcome in our public places. So lighting is used to enhance our public places, particularly to illuminate trees, gardens and parks, buildings and to highlight the artistic, architectural and natural characteristics of those places. It also can extend the use of our public places by providing sufficient light to circulate and to play. And it can improve our public places by improving safety and enjoyment after dark. However, if it's poorly designed or executed, then there can also be negative effects to our visitors, neighbours and the environment. And so a basic understanding of lighting can help us improve outcomes. And that's the purpose really of today's webinar. So without light, we can't see. Without surfaces to reflect off, there's nothing to see. And to understand the relationship between the source of light and the surfaces that reflect light and how we see light, we need a new language, and quantifying and qualifying the nature of light within a space calls for an understanding of some certain lighting terms. And so we're going to focus the first part of the webinar on some of these lighting terms, what we call the language of light, which we'll be able to use to communicate with lighting designers and the like. So the first unit that we need to understand is the lumen, which is the total amount of light emitted by a source, and it can be any light source, but it's important to think about it as energy flowing out from their source. So typically a candle generates about 12 lumens, and a standard 60 watt incandescent lamp that you might have at home is rated about 890 lumens, and a sports light is around 220,000 lumens. So you can see generating a lot more light. So think of it like a little bit like water. Something's energized and the light flows out from, photons flow out and then, reflect off surfaces. And so when they reflect off a surface, we determine that to be illumination. And we use the unit lux as the unit of illumination, being 1 lumen per square metre is 1 lux. And so here we've got a street light, and if we put our light meter underneath the street light, we could possibly be recording 20 lux, which is 20 lumens per square metre. And the further we go away, we get down to 1 lux. So it's a very good measure of the illumination of surfaces. And we can adjust where we measure those surfaces. We can put our light meter on a table, which is not on ground level, so that's 750 mils above ground level, for example, and we will get a brighter reading than if we put it on the ground level, because, of course, as we go further away from the light source, the intensity of illumination is diminished as it's spread more evenly over a given area. The candela is the intensity of light in a particular direction, and this is really important to understand, that just like holding a torch, if you shine the torches in your eyes, there's a direct beam of light coming into your eyes, so it appears to be very bright. We try to avoid the use of the word brightness because it's very subjective depending on the adaptive state of your eye, and you'll know if that you come out of the movie theatre, having been in a dark environment, your eye will take some time to adapt to the bright light. Of course, the light level hasn't changed. It's still daylight outside, hasn't got any brighter. It's simply that your eye has to adapt. So we need to measure the true level of intensity of light, and that's where we use the candela. And it is important to know that it's in a particular direction because it will vary, just like your car lights. If you look directly into them, they'll be very bright. But if you stood on the side of the car and looked to them, they wouldn't be so bright because the intensity is greatest in the forward direction for driving. So just to summarise, here's our the 4 key units that we need to understand. Lumen on the top here, the total amount of light in all directions coming from a source. Intensity with using candela, the light in one particular direction. When that light falls on a surface, we call that illuminance, measured in lux. And when it leaves the surface in a particular direction, that is called luminance. So when we're looking at a road, when we're driving our car, we're really seeing the luminance. We're seeing the light reflected off the road. So they're the difference of those units. For park lighting particularly, and lighting of paths and cycleways, uniformity is a very important thing. And how we establish uniformity is we put a grid of measurement points over our path. And if we take the average of all of the illuminance levels on that path and we compare that to the maximum level of illuminance, which will occur underneath the street light, then we have a measure of uniformity. And you can see here that this path has quite poor uniformity. We go from bright to dark, bright to dark, bright to dark. And this effect, the sort of zebra crossing effect, can be quite dangerous because of the adaptive state of our eye can't adapt quickly enough. And if you're on a bicycle and you're going from light to dark, it can be quite distracting. So by putting the maximum divided by the average, we get the uniformity level. So the lower the number, the better the uniformity. And here's a park with quite poor uniformity. We've got one bright light source within the park, and like a moth to the light, we could be drawn into the park, and then only to find that the balance of the park is quite dark. Here's a path with very good uniformity, which is a particular requirement for roading and for paths and also for sports fields, because you can imagine if you are following a ball or something, it needs to be uniformly lit across the sports field. But it can also have the effect of being a little bit bland and uninteresting, and so careful design's needed to ensure that the key areas have uniformity while the features are highlighted. Colour rendering index is an interesting area. It's the blue screen here is our reference level, and daylight we give a value of 100, and we can compare the blue Peugeot there is in the daylight, so we have a CRI of 100, and then if we look at a low pressure sodium light here, which on the right, which is not commonly used these days, that has a very poor colour rendering with a CRI of 0, and we can see that the car is really indistinguishable to the colour, may appear brown or black perhaps. If we look under high pressure sodium, which is quite a common light source, that's the typical orange light that you would see on a motorway, you can see that the car now looks purple. And there if we look onto the metal halide or the LED, we can see that this has a CRI anywhere between 65 and 90. And once again, our car now looks blue. And of course, this is important because if we were wanting to look at plants, or if we were wanting to identify a vehicle that perhaps was involved in an accident or something, we'd want to know the true colour of it. Or if we were buying some clothes in the shop, we would want to know that the colours are true to natural light. So CRIs are very important for park lighting. So here's an image, high pressure sodium, low colour rendering, everything looks uniform in colour, and contrast that to all the true colours that are available in nature, and how we're really underselling what we have to offer at night. A lot of effort these days, of course, is on efficiency, energy efficiency, and we have a term called efficacy, which is the lumens per watt that a given light fitting produces. We can compare the two products on the screen here. The product on the right has an efficacy of 120 lumens per watt, which is very energy efficient. And it's important to know that you need to get the system lumens rather than the lumen output of the LED module. So an LED module will have a number of LEDs here which come as a little array, and the manufacturer of those LEDs will tell you how many lumens they put out when they're energized. But when we put it inside a light fitting and we require a transformer and we have wiring, we use some energy in the delivery of the light from the lumen package. And so it's important to understand exactly how much energy the whole light fitting or luminaire is using. In this case, it's 29 watts, giving us a efficacy of 88 lumens per watt. And on the right, we're getting 29,500 lumens for 24 watts. So we've got a more efficient fitting, 122 lumens per watt. Okay, colour temperature. This is also an important aspect. We use the measurement called Kelvin, and you'll often hear people talking about cool white or warm white. If you're buying some light bulbs for home, the lighting store might ask you, do you want warm white or cool white? And you would typically put your cool white being around the 4,000 to 5,000 Kelvin in your kitchen, and you might put the warm white, hopefully the 3,000 Kelvin in your lounge or in the bedroom. And if you're using multiple light sources, it's important to select and to maintain these consistently. And in this museum display here, we can see actually that all display cases are actually all the same colour, but various light bulbs have been put in over time, or they've degraded over time because of being poor quality bulbs, and this has an effect on the colours that we see. So it's important to specify the right colour, the appropriate colour for the setting, and then maintain it. And we'll talk more about the importance of colour temperature later. So that's all the technical part, and in summary, lumens, the amount of light output; candela, the intensity in a particular direction; lux, the quantity of light that falls on a surface measured by illuminance. Luminance is the intensity of light in a particular direction, and CRI, our colour rendering index, and Kelvin, our colour temperature. So those are the terms that hopefully you're familiar with, and hope you've been taking some notes because there is a wee test at the end. So we'll briefly now just talk about some of the sources of light. We probably won't spend much time on this because LED is really becoming prevalent now as being the best light source, or the most energy efficient light source with the lowest maintenance cost. And this is useful to understand the current sources of light so that you understand why it's a good idea to start changing these sources to LED. If you were going to change if you're looking at your park lighting and you want to, what you have now, if you came across mercury vapor, it would be a technology that you would want to replace because it has very, very low efficiency, only 35 to 60 lumens per watt, and very poor color rendering. It does have quite a long life, however, but that life diminishes very quickly towards the end, and you get a very, very little light output, but the light bulb still goes, and so it's often left long beyond when it should be replaced. So, as well as having some nasty chemicals in it, it's a good light source to replace and very economic to replace. You'll probably have quite a lot of fluorescents around still, and they can be quite an efficient light source, but they generally don't put out sufficient light for park lighting, the paths, etc. You'll certainly have high pressure sodium, very efficient, but very poor colour rendering. This is that orange street light that we've been seeing. And increasingly, this is the focus of replacement programs to LED. Before LED really made headway, metal halide was the new technology, and this was because it had good efficiency but very high colour rendering, and a lot of effort in sort of late 90s, early 2000s was around changing high pressure sodium sources to metal halide. But the relatively short life of the bulb and the cost of the bulb means that really this has been superseded by LED. Cosmopolis is an advanced metal halide lamp, and this was totally overtaken by LED. So it was developed really right at the end of, or beginning of LED becoming recognised as being a very efficient source. So a really nice light, but really hard to justify why you would use this over LED now. So here's LED. It's a point source. It's a diode. When that diode is energized, then it produces light, and phosphors are used to generate various colors of light through the light spectrum. It can be very tightly controlled, so we have less spill light. It can potentially have less light pollution because of the control of it in terms of direction. Can be very efficient, and of course that results in energy and CO2 savings. The LED itself, of course, doesn't last forever, and when the LED is replaced, my view certainly is that the whole luminaire will be replaced, and this is a factor that you need to think about in terms of asset management, because most typical park lights have been around for 30 years, and you just keep changing the light bulb and it comes back to its original condition. With LED, it will degrade and you will end up replacing the whole light fitting. You won't be changing the light module because I think the technology will have moved on within this short time. And this graph really illustrates how over the years the various light sources we've described here, the black is the high pressure sodium, sort of became on the scene in 1961, and a gradual increase in terms of efficiencies to get up to around the 120 lumens per watt. And if we look at LED starting in 1994, you can see the rapid improvement in efficiencies. The graph goes up to 150 lumens per watt. I think that's pretty optimistic, and most of the true system efficiencies we're seeing are more around the 120 lumens per watt at the moment, but they will get there. So what we're looking for in an LED light, we're looking for a reputable chip. Those little LED chips, they are made by several different manufacturers around the world who supply them to light fitting manufacturers, and some are of poorer quality than others. So we need to look for people that have got good warranties and have been making LEDs for a long time, leaders in the field like Cree and Osram and Nikita out of Japan, etc. They need a good heat sink. They need to control the heat. If an LED is put without a heat sink, then it will have a very short life. And it's also, if it's put in a very hot environment like a desert, for example, again, it will have a reduced life. So we're looking to try and get at least a 20-year life out of your LED. That, of course, will depend on how long you operate it for. 10-year warranty now is quite standard. And for park lighting, I believe we need to look for a 3,000 Kelvin maximum temperature, which is creating this warm white light, unlike the cooler light in this photo here. High colour rendering, at least 70, good optical control, and good efficiencies. So LEDs certainly revolutionised lighting both for exterior and interior applications. The LED chips and luminaires really have been developing at an incredibly impressive rate, but they're not all equal, and you need to do your research and understand the quality and long-term performance of the LED and what sort of a warranty that you'll have for the product. And the evaluation of those LED products is significantly different to evaluating traditional fittings and requires different skill sets and different units of comparison. So we talked a little bit about depreciation. Whenever we buy a light bulb, it starts to depreciate over time. The level of light output reduces as the light gets older, light bulb gets older. And the typical life we're expecting out of a street light, for example, is 20 years or 85,000 hours. And that's based on operating at around a bit over 4,000 hours a year. But if you purchased a light fitting that only had a life of 50,000 hours and you ran it for the same time, you'd see that you'd only get 11.7 years out of the fitting. So that's quite a big difference. And if you might be paying $1,000 for your light fitting, that's almost double the depreciation that you would need to allow for in your asset management planning. Maintenance for LED is typically only the cleaning and sometimes potentially the replacement of drivers, which are the transformers that convert the high voltage to low voltage. But the light output's only partly restorable during maintenance. For example, we have our HID, our high pressure sodium light source. Every time we change the light bulb, we hopefully clean it, and we get a resulting lift back to almost its original performance. And this is important because when we design lighting, we design for its depreciated state. So we typically design for how much light we need at the end of its life cycle. So for HID, we design for typically around 0.7, so 70% of the light output, and we make sure that we've got the right light levels for that. With LED, it's depreciating constantly, and while we can clean it, we might get a small lift. We don't get that total replacement, and so once we've reached the end of our life, the product really needs to be replaced, and that means we have to use the right maintenance factors and understand what those are in our design. So important considerations then are what is the whole of life cost? If we're replacing that light, what will really happen? Will the light still be available? Will the improvements in LED efficiency mean that I won't actually replace the module, but I will replace the whole light? I think that's the case, and I think you should assume that the life of the LED module is the life of the light fitting. And when we're considering whole of life costs, we need to consider the capital cost of the luminaire, the energy cost over the life of operation, maintenance cost, including lamp, driver, and labour, cost of capital, and disposal cost. And all of those things will give us an ability to compare our purchase decisions with our existing operating costs. And typically the paybacks for LED can be anywhere between 3 to 7 to 10 years, depending on your operating hours. Operating hours typically is the key factor. What colour temperature? You will find that most LED street lighting is specified at 4,000 Kelvin, being cool white. And as has been the case in the past, typically many of our lighting decisions are influenced by our roading colleagues, our roading engineers, and councils typically will go with the light fitting that is used in the roading network as well, which is not necessarily the best thing for parks or public spaces. And there is considerable and growing concern over the public health and environmental risks of the blue light component in LED. For this reason, 3,000 Kelvin is recommended for all lighting in parks other than sports field lighting because of the reduced blue light, meaning reduced health risks, reduced impact on the night sky, reduced impact on wildlife, and it creates a more welcoming and comfortable appearance. So always check what colour temperature you are specifying for park lighting. Here's the wavelength produced by various types of lighting sources. And if we have a look at the green line there, we've got 3,000 Kelvin. Towards this 450 nanometer part of the lighting spectrum is this blue spike. It's the blue end of the spectrum. And you can see that our 3,000 Kelvin LED has significantly less blue light than a 4,000 Kelvin LED. So, right up at 1, down at 0.4 for 3,000. So just by changing that colour temperature down to 3,000 Kelvin, we will significantly reduce the amount of blue light, which is the aspect of lighting that's causing a lot of concern internationally. There is a reduced efficiency with 3,000 Kelvin. It's around about 10 to 15%, but the benefits, I believe, outweigh the disadvantages. So we need to consider what the expected life of the LED is, establish that rated life. The way that's done is that products are tested for 6,000 hours. They can't obviously keep the product in testing for 10 or 20 years before they release it. So they test it for 6,000 hours continuously, and then they use a standardized model to forecast the remaining life. You can look at the rated life at various depreciated stages, and this measurement here is the standard term that we use, which is L70 at 85,000 hours. And this means that at 85,000 hours, after 85,000 hours of use, the luminaire will produce 70% of the original light level. So you might see L50 at 100,000 hours. That would mean after 100,000 hours, only 50% of the original light is put out. So you want to be comparing apples with apples and getting the L70 or the L90 figure, and then comparing the available hours of light left. It's very important because it's often I find manufacturers use different numbers, and it's not easy to make good comparisons. And then what's the quality of the luminaire? Is it reputable chips? Are all the components covered by warranty, not just the LED module? What's the optical performance? Is it waterproof? What controls are available? Those are dimming controls, etc., that might be useful. And what is the bug rating? And bug rating is a very useful thing for parks and public spaces because it's a measure of the amount of backlight that's coming out of the fitting. Backlight is in this part of the light. If we have lots of backlight, then we're going to cause potentially problems for neighbours, or it might be useful in terms of making sure the edges of our paths are lit. We want to have zero uplight. We want to ensure that there's no impact on the night sky, because we want to make sure that people can enjoy the stars in our public places. And we want to control light trespass, glare light into neighbouring buildings and houses. So if we can, every fitting will have this bug rating, BUG, and if we look at the numbers, a BUG of 101 is a very good fitting in terms of its light control. So look for a similar glare rating. Okay, just bear with me. I'm having some issues in terms of how to change. There we go. Okay, so we can have a great fitting, a fitting with no upward spill light, but if we mount it almost vertically like this, and this is extremely common, that electricians will come and they will tilt the fitting to try and get more light onto the target. And what they're doing in doing that is they're producing a lot of light spill and also creating a lot of high glare. So we need to be very careful to avoid that. And this is the result in daytime. You can see those light fittings now, rather than being focused on the sculpture, are actually just like headlights pointed directly into our eyes. It's very common with sports lights. This is because people put the poles at too low a height, and so they need to tilt the lights to try and get the light out into the centre of the field. And typically for a rugby field, our minimum lighting height is 16.5 metres. So you've got to get the lights up high so that you can control the tilt angle. And we use a light fitting, specialised light fitting that pushes the light out into the centre of the field. So if you see fittings that are tilted on high degrees, particularly LED fittings that are put on existing poles and are tilted above the horizontal, then there is going to be significant glare and significant upward light, creating light pollution. So you want to get that fixed. And that light pollution also has impacts on wildlife. We know that natural light is used by organisms for various things, for finding resources and also for information within ecosystems. And this diagram is quite a useful way to illustrate the difference between natural light and artificial light, and how artificial light can affect the spatial patterns of wildlife, the timing of mating or various cycles of feeding times, etc. And the spectral composition of light, that blue light spectrum, also can impact on things. So light can be a resource. It can help with photosynthesis, can help us to know when to sleep, etc., or go into hibernation. It can help repair and recover. It can also be used as an information source in terms of circadian rhythms and visual perception and spatial orientation navigation. So the effects of lighting on wildlife are becoming more and more prevalent, and I think what's been really found in the research is that it varies widely across species. So if you have a particular natural area that has bird life or turtles or particular insects that are special that you're concerned about, then you should try and establish what research is available for that particular species in terms of their response to light sources, and then look to see whether your lighting may or may not have impacts on wildlife. So it's a developing area. There's not a lot of information, but do be aware that lighting will impact on wildlife if it's not carefully considered, and it might mean that you need to use warmer colour temperatures than even 3000 Kelvin to reduce the effects, or use controls so that lights are turned off after, say, 10 p.m. Or when animals are coming in from the ocean or something like that. So a variety of techniques can be used. So how do we know we've got the right amount of light? Is this the right amount of light? It looks a lot to me, and it looks pretty unwelcoming. The way we do it internationally is that countries will have standards. In this part of the world, we use the New Zealand and Australian standards, but there are also American standards and European standards for lighting. And depending on the type of area that we have, the population, the use, the risk of crime, etc., we will consider the light levels that are required, and we'll determine the type of illuminance level that we need to design to. And so when you've received the design, it will typically be designed to some standard. And it's important to understand what that standard is and consider whether it's the right standard for your application. Each light will have a contour map showing around it, which is we call an isolux plot. And that contour shows the level of illuminance coming out, decreasing as it gets further away from the fittings. And here we can see the gaps between the low light areas between the red lines. And it might well have these point sources. So you can see there's a grid of numbers here. Those are computed values for illuminance at those individual points. So at the top of the screen here, we can see directly under the light, we've got 36.4 lux. And between the lights, we can see we've got 2 lux. So, quite a big level. And if we calculate those out, as you know, we can look at uniformity, etc. So that's a typical isolux drawing. Here's the one for a pathway. We can see we've got quite good uniformity. The contours are not separated, they're joined. And we can see that our light spill is quite limited. We only need to go a few meters off the path and we're down to 0.1 lux. So you can imagine that this will be a very well lit path, very uniform lighting, but with very little light off to the sides. So let's just have a look at the sort of typical setting. This would be the daytime aesthetic for that type of a design, using a sort of high quality fitting. And this would be what it would look like at night. Good performance, very limited in terms of dark and light patches, and good lighting control. Very comfortable to look at. Another scene, nice sort of daytime appearance, which is important for our parks and public places, but also good nighttime performance. Again, not LED. This is using Cosmopolis, warm colour. Very sort of welcoming environment. Here we can't see any light poles, so we've got a very nice, uncluttered daytime look, and at night we've got a very kind of impressive and striking effect by integrating the light fittings into the handrail and giving us exceptional light levels on steps, which is important for safety. So just a couple of examples of the techniques that we can use. So for good park lighting, we need the right amount of light in the right place, with good colour rendering, good uniformity, good daytime aesthetics, and great nighttime performance. It needs to be energy efficient, cost effective, long lasting, and it needs to be on the job. So if we combine all of those things, we can determine that we've got good park lighting, I think. So often you'll be encouraged to put lighting as a response to crime, and there's been a lot of work done on this recently, particularly by a chap in Australia who's really made it his lifelong mission to study this, and the work that he's done is to show that statistically there's a very poor relationship between high light levels and low crime. So if you think about a city centre, of course, that has a lot of light. City centres are much, much brighter than suburban or rural areas. Yet, of course, most of the crime occurs in city centres, and that's typically a function of other factors, including the density of people and alcohol or other social factors. So you can't say simply because we make areas brighter that there will be less crime. There is no real relationship. What lighting can do, though, of course, is make people feel safe. And if we create a light area and the area is inherently unsafe, then perhaps that's just creating a false sense of security. And we'd be better off to ensure that we use our crime prevention through environmental design principles and perhaps light the perimeter of the park, just encouraging people to walk around the park where there might be residential housing, offering passive surveillance, rather than creating a path through the park where there may not be the passive surveillance available that might be a factor in reducing crime. But if there are people around and there are opportunities, and we should light well. And particularly if you're using things like CCTV, you will require good light levels. And I think if you had two streets in a city and one was unlit and the other was well lit, then most people would choose to use the lit street. So we need to make sure that our effort around lighting is well considered. If we light things poorly, then we might well be creating an unsafe situation. So here's an example. We've got our well-lit toilet, but the path from the car park to the toilet is very poorly lit. And, that can create limited passive surveillance, and it creates an unsafe feeling. It may not be inherently unsafe, it just simply doesn't feel safe for our visitors, so they're uneasy. And I think a good rule of thumb is if it's not safe, lighting's probably not going to help. And here's an access way that I was asked to have a look at for lighting. And the reality is that it's got a very blind corner, no passive surveillance. Much better to encourage people not to use this by not lighting it at all, getting people to take an alternative route and lighting that alternative route well. When we're lighting, we need to consider the vertical illuminance. So we talked before about having a light level, luminance level on the ground. If we put our light meter in the vertical against our face, we can measure the amount of vertical illuminance that a particular lighting design will produce. Here you can see some bollards. Bollards are quite popular for parks agencies because they don't look so much impact as light poles in a park. However, they generally produce high glare and very, very poor vertical illuminance. Not sure if you saw the person coming towards you in the scene here, but there's almost no vertical illuminance. We can't read their face, we can't read their intentions, we can't make our own decisions about what we should do. So low-level lighting, poor colour rendering, poor vertical illuminance, resulting in not a very pleasant or safe walkway. So finally, if you're considering how to approach lighting in your public spaces, you might want to consider thinking about producing a lighting master plan. And the first step for that is for you to understand what assets you've got out there now. And generally, you'll be surprised at the number of lighting assets you have. Often these are underreported. We're very good at counting trees, park benches and rubbish bins, but not so good at counting lights and understanding their conditions. So get a good handle on the asset information. Review the fittings in terms of what's the cost benefit of changing them to LED. Do they have any historical importance? What's their condition like, etc. And develop up some maintenance actions to improve the lighting. Consider the crime prevention through environmental design issues with the public space. What might you need to do around improving it? And then look for the opportunities to create and highlight the special things, whether it's sculptures, trees, fountains, or creating a dark sky environment or a dark sky reserve, perhaps for your park or public space. And if we put all of those things together with a work program, then we've got a very good lighting master plan that we can progress with. So thanks very much for attending today, and I hope that you've found that valuable and given you some insight into public space lighting and parks and recreation. Thanks very much.
Thank you, Paul. That was a fascinating presentation. I certainly learned a lot, and I'm realizing how much I take lighting for granted. So thank you for sharing with us today.
You're welcome.
Let us take 10 minutes for questions. If Digby or Eric, do you have any questions for Paul today? If you could introduce yourself and let us know where you're coming from, that would be great.
Yeah, Digby here. I thought that it was fascinating. Thank you, Paul. Good mix of technical and the outcomes we're trying to seek. And it occurred to me that you're a little bit more at the leading edge of good lighting design, and it must vary between countries, I suppose. But if you took New Zealand, I wonder where you would put most city parks departments on a spectrum. Perhaps LED hasn't been around that long, and they haven't really thought about how effective lighting could be. But I presume many of us are still at the beginning. We've got a lot of potential to upgrade our parks.
Yes, absolutely. I think we're certainly at the beginning end of the spectrum, and as parks managers, we I think often have taken our advice from the lighting experts in our organisation, which are offering the roading managers who really are looking at lighting from a different perspective. They're looking at it from a vehicle orientated perspective predominantly, and are looking at it totally in terms of efficiency, lowest cost, rather than looking at it from a human perspective and the effect it has on people and the environment, and how lighting can be both an attractor, an extender, etc. of our public space use. So, yeah, we're certainly at the beginning, and it's important, I think, to get good advice and to question what you're given in terms of lighting decisions. Yeah.
Yeah, I suppose it's also, but it's quite an expense, so it's good to phase it in with the asset life cycles of parks. I mean, obviously, where parks are renewed or they're new parks, is a good opportunity.
Yes, very true. Yeah.
Yeah, thanks, Paul. That's a good grounding for the uninitiated. It gives good information for us to tackle those discussions with the roading departments.
Good, Eric. Yeah. Okay. No, that's very much appreciated.
And we have a question from Matthew. Is there a central database and or software that is can be used to track lighting assets similar to trees?
Yes, many organisations will have an asset register which will record the lighting information, but often it's quite limited. It's generally the asset work that our company's done around lighting. We often find that just the light source maybe is recorded, or that it is a light, or the type of light. It's a bollard, it's a street light, but there's limited detail on the wattage, the efficiency of it. Its condition is often not recorded, and because lights are not necessarily point assets, I'm meaning that one pole might have 3 lights on it, and that's often recorded in an asset management system as one light. The numbers of lights are often grossly underreported. So we would typically find an organisation in New Zealand would have around 400 to 700 lights in its parks and network. And when we when we're asked to start on this project, we typically give an asset register of around about 100 lights. So we've generally found that it's heavily underreported, the amount of lighting assets that people own. And when you consider that a park bench is maybe worth $1,000, but it doesn't use energy and it doesn't have any public safety element to it, and yet a street light might be worth $7,000 when you consider the cabling, the pole and the fitting, and it uses energy every night, and can be very annoying for people if it's not working when they're using the park. I think we kind of undervalue the importance of it.
Well, would you consider any countries are a little bit ahead? Maybe Europe, don't know.
No, I think Europe is very strong in lighting. A lot of lighting manufacturers in Europe. I think probably Europe is very strong in this area. Some cities in Europe I've visited before. Paris is a specialist lighting department that's been around for over 30 years that tests all of its public lighting, is well aware of all of these types of issues. and some cities pride themselves in being centres for lighting. So Lyon, for example, is a recognised lighting centre. And no doubt you've seen internationally the rise in lighting events, and so Vivid in Sydney, and I'm sure throughout the world people are seeing lighting events now as being a great thing to have in public spaces, to be able to bring people and artists together at night into our park environments.
Yeah.
I got to run, Paul, so thanks for that.
Yep, no, very good, Eric. We'll catch up again soon.
Will do. Cheers, mate.
Okay, thank you.
I think how we circulate this, Paul, so it gets a good uptake. I think it's a nice grounding for park managers to have.
Yeah, okay, no, that's good. I know it's been my pleasure to put together, and sorry we weren't able to attract a few more, but yeah, thank you.
It's a live recording and it will live on.
Very good.
It is live recording, and Paul has also put together a short assessment for anyone wanting to get continuing education unit credit, which also transfers to 1 hour of continuing professional development toward a World Parks Academy certificate. So check that out on provalenceLearning.com.
Very good.
Very good. Thank you very much, and thanks very much, Hannah, for your work in putting this together and making it happen, and for the invitation. Much appreciated. Thank you very much. Have a good evening.
Thank you, Paul. Really enjoyed it.
Okay. Thank you.
All right.